Once considered a planet, Pluto is a small, distant object. Recently, space experts Naku and Neil deGrasse Tyson have brought Pluto back into the news. They're suggesting Pluto might collide with Neptune. And they're not just guessing, they're warning us. If Pluto gets too close to Neptune's path, Tyson and Naku fear that even a slight change could cause a disaster. Though now classified as a dwarf planet, Pluto still fascinates scientists. Current models show it passes very close to Neptune's orbit, and Tyson and Naku warn that the two could one day collide, which might even affect Earth. Pluto's trip around the Sun is unusual. It takes 248 Earth years to complete, and since its discovery in 1930, it hasn't finished one full orbit. Its path is highly stretched out and tilted compared to the other planets, which complicates matters. Interestingly, Pluto's orbit crosses Neptune's for about 20 years each cycle, meaning Pluto is actually closer to the Sun than Neptune during that time. The gravity of nearby giant planets plays a role. Studies of Pluto's path began soon after its discovery, and astronomers have tried to understand its odd orbit ever since. While most planets circle the Sun on a flat plane, Pluto's path is tilted and uneven. The fact that Pluto's orbit is stable, despite crossing Neptune's, shows how orbital mechanics work. The three-body problem, how Pluto, Neptune, and the Sun affect each other through gravity, is key to this. Predicting their future positions depends on knowing their starting conditions and how they pull on each other. Concepts like asynchronous oscillation, orbital drift, and the VZK wobble help explain this balance. Asynchronous oscillation means that when Pluto crosses Neptune's orbit, it is always far enough away to avoid collision. Orbital drift ensures Pluto stays above or below Neptune's path, adding another safeguard. The VZK wobble, named after Zeldek and Kaku, describes how the Sun, Pluto, and Neptune tug on each other, keeping Pluto's orbit stable even when it seems chaotic. These dynamics prevent Pluto from crashing into Neptune or being ejected from the solar system. Computer models from the 1980s showed Pluto's orbit is stable but sensitive. Small changes early on could cause big effects later. Fortunately, its path has remained steady for billions of years. Neptune, Saturn, and Jupiter all help stabilize Pluto's orbit. In fact, Pluto and Neptune are locked in a 2:3 orbital resonance. For every 2 orbits Neptune makes, Pluto completes 3. This cosmic rhythm ensures they never meet. Jupiter and Saturn's gravity further strengthens the stability, effectively protecting Pluto. Still, orbital chaos means even tiny changes to Pluto's position or speed could alter its path over time. Simulations confirm that Pluto's orbit can be unpredictable, but its underlying stability has held for eons. Tyson warns, however, that small disturbances accumulating over millions of years could eventually cause chaos, or even a collision. Other scientists, such as Michio Kaku, agree. They emphasize how delicate planetary balances are and how small shifts could have enormous long-term consequences. While not an immediate threat, a Pluto-Neptune collision remains a theoretical possibility far in the future. In conclusion, Pluto's strange orbit shows how fragile yet stable our solar system can be. Forces like asynchronous oscillation, orbital drift, and the VZK wobble keep Pluto safe, while giant planets provide further stability. Still, the possibility of long-term orbital chaos reminds us how much we still have to learn. Pluto remains a cosmic puzzle, its orbit a lesson in the balance between chaos and stability, and a reminder to keep watching the skies. Pluto's story is more than just about one icy world at the edge of our solar system. It's also about the rules of gravity, orbital mechanics, and the hidden balance that keeps our planets in motion. Every time astronomers look deeper into Pluto's movements, they uncover not only new mysteries about Pluto itself, but also about the long-term stability of the solar system as a whole. If Pluto and Neptune were ever to collide, the event would release an unimaginable amount of energy. The sheer force of such an impact could send shockwaves throughout the solar system, disturbing other planetary orbits. Earth would not be in direct danger from the collision itself, but the ripple effects on orbital balance could, over millions of years, change the delicate structure of our neighborhood in space. But here's the crucial part. Everything we know suggests that such a collision is extremely unlikely. The orbital resonance, the stabilizing influence of Jupiter and Saturn, and the natural oscillations of Pluto's path all act like a cosmic safeguard. It's almost as though the solar system has invisible safety nets built into its design. Still, Tyson and others remind us that the universe is not a static clockwork. Orbits shift, gravitational pulls evolve, and chaos theory shows us that even a tiny change in initial conditions can lead to completely different outcomes over time. What looks steady now might, in billions of years, look very different. That's what makes Pluto such an important case study. By studying its orbit, scientists gain insight into how other planetary systems might evolve. It helps us understand exoplanets, distant star systems, and even the long-term fate of our own solar system. So, while Pluto is unlikely to crash into Neptune anytime soon, the discussion itself is valuable. It forces us to ask, how stable is the solar system really? And if it can happen here, what does that mean for the countless other star systems across the galaxy? Pluto's orbit is a reminder that even in a universe that often feels predictable, uncertainty is always lurking beneath the surface. The cosmos is both stable and fragile, an endless dance of order and chaos, balance and disruption. And perhaps, just like Pluto itself, our place in the universe is more delicate than we realize. For billions of years, the solar system has appeared stable. Planets follow their orbits, moons circle their hosts, and the sun provides the gravitational anchor for it all. Yet history shows us that cosmic stability is never absolute. Collisions have happened before. Planets and moons have been shattered. Asteroids and comets have bombarded worlds, changing their fates forever. Pluto and Neptune's near-collision scenario is not a prediction of doom, but rather a reminder of how fragile balance can be. Our solar system is a masterpiece of gravitational choreography, where even a tiny misstep could rewrite the future. Think about this. Jupiter alone has shielded Earth countless times from catastrophic asteroid strikes, pulling dangerous objects away with its enormous gravity. Without Jupiter, Earth itself might have been uninhabitable. In the same way, Neptune's gravitational rhythm with Pluto prevents disaster, proof that chaos and order are locked together in an endless struggle. But what if, far into the future, that rhythm falters? A passing star could tug at Neptune's orbit. A distant object from the Oort cloud could drift inward and disrupt the balance. Even the slow loss of the Sun's mass over billions of years could gradually loosen the solar system's grip. Over cosmic timescales, stability becomes an illusion. Astrophysicists like Tyson and Kaku warn us that this is not just science fiction, it is physics unfolding on a grand stage. The three-body problem, chaos theory, and orbital resonance aren't abstract equations. They're the laws that govern whether planets survive or collide. And so Pluto becomes more than just a frozen dwarf planet at the edge of the solar system. It becomes a symbol of the thin line between chaos and harmony, a case study in how gravity can both protect and destroy. Perhaps that is why Pluto still captures our imagination. It's not just about whether it is a planet or a dwarf planet, it's about what it represents: uncertainty, instability, and the reminder that nothing in space lasts forever. One day, billions of years from now, the solar system itself will unravel. The sun will expand into a red giant, swallowing Mercury, Venus, and possibly Earth. Orbits will shift, moons will scatter, and what seems stable today will dissolve into chaos. Pluto's delicate path is a preview of that inevitable future.